So just a quick another public service announcement. If you see someone post a question on Piazza and you think you know the answer to it, it will help tremendously. It will help the course staff if maybe you could reply to it. And then we can give you like an endorsement, and then it also helps us recognize who is helping other students in the class, and that will help us grade you higher when we eventually give you your final project grade. So yeah, it just really helps a lot if by chance, if you have time to respond to other students' questions. Oftentimes, student answers can even make more sense than instructor answers because you're in the shoes of the person doing the assignment. Yeah, question?
So we get extra credit when we do comments?
So when we eventually grade the final project, the way that we are grading the final project is based off of your contributions to your group. And if we recognize your name, we really have seen that this person has engaged in this class a lot, that means that you will get a higher score in the class. If we recognize your name, if we see that you are contributing both like to your group and also maybe contributing to class Piazza posts, then that will give us more of a reason to give you a higher grade. Yes, it wouldn't be extra credit. It would just be like just grading you more accurately to the work that you've been putting into this class. Yeah, great question. On Friday, I published a debugger lecture. Okay, anyone watch that? Okay. Debugger's extremely, extremely helpful for the next part of the lab. Honestly, in my opinion, I felt like debuggers are not as useful when doing CPU emulation stuff, and the reason for that is because you kind of want to debug the program itself, like the slug file, but when you debug the slug file, there's all of your C code that's being kind of in the way. So it's honestly a little bit tricky. What it's great for is for graphic stuff, where it's the screen is not displaying the correct pixel there. It's what's happening? Going line by line and finding out exactly what is corrupting that single pixel or something. That is very helpful. So highly recommend getting a debugger set up. It will end up saving you tons of time. Another thing is if you show up to a job interview, especially in this job market, and you're like, I know a lot of C++, I'm really experienced in this. I took a whole class where I designed a GPU, I designed a whole emulator. Your interviewer is going to be super impressed by that. They'll say wow, that's so cool. You're doing a low-level project and really exploring a lot of C++'s features. And then they ask you, okay, well, I have a question for you then. How would you find a seg fault? Okay, so your interviewer asks you this, and there's one correct answer. And if you mess up this answer, then they immediately take your name off of the interview list. Okay, so what is the correct answer? How do you find a seg fault? What is the fastest way to find a seg fault? Yeah. Okay, tell the person next to you, how do you find a seg fault? What is the fastest way? Okay, yeah, anyone? How do you solve a seg fault? Okay, yeah. Yeah, absolutely. So GDB backtrace. So GDB, so C++ debugger from GNU. And then backtrace will show you all of the different functions that it took in order for it to eventually run that one command that caused the seg fault. Yeah, the issue with seg faults is that when you encounter one, it's really hard to even find what line they trigger on because it's an operating system error. It means that you've just run a program that has a bug so severe in it that your operating system needed to step in and say, hey, I can't run this or else the computer will be vulnerable and it will break everything. So a seg fault means that the operating system steps in and ends the execution, which means that the operating system has no clue what line of code something will be erroring out on, because your operating system doesn't care what error or what line the seg fault occurs on. Yeah, but GDB will tell you exactly what line you're getting the seg fault on. And yes, in this, specifically with getting SDL working, which is my personal favorite kind of graphics library, you're probably going to find a few seg faults, and that's probably going to be maybe just small problems with setup and things. SDL, unfortunately, is not like a super safe language. It doesn't throw a ton of exceptions, and so you might just get seg faults. It's really helpful having GDB for that. So yeah, please get that set up. Okay. I will not be giving a tutorial on SDL, like in lecture. I'm happy to answer some questions, but I think there's so much good information online, and a lot of it's kind of just boilerplate. I'd recommend just kind of, you could ask ChatGPT, you could find things online, you could find other starter code. The overall learning outcome of getting SDL working is more just the action of pulling in a third-party library and then figuring out how to use it. I don't necessarily want you all to become experts in SDL, so I'm actually not going to give a lecture on how to get SDL working, but I think that should be fine overall. If that ends up being terrible, then you're welcome to ask me some targeted good questions, and I can give a lecture on that. But yeah, so I think it should be, and this is what happened last course offering too, is I did not give a lecture on SDL, and I think actually that made things even better because it meant that everyone had to explore it on their own and learn it on their own, which actually helped. Yeah, question?
So, yeah, I wanted to ask if there's any resources that you can give regarding SDL, because while I did get the ChatGPT and activating like a solution, there's some bugs with it that I didn't really jive with me.
Sure.
Like when you like full screen and like so you can still see like a window, it like doesn't completely encompass the whole.
Yeah, that's a good question. So just are there any resources for SDL2? I don't know any off the top of my head, and I don't remember what resources I was looking at when I was first learning about it. Does anyone have any favorite resources that they've already been exploring? SDL resources? Yeah. Well, if anyone could put any of their favorite resources in Piazza, that'd be great. I can look for a few. That's totally reasonable. Yeah. Okay. Let me write that down. So. Okay. Wow. So this is the instructor solution. This is Flappy Bird. And now it's running. Okay, I won't do the first one. But there we go. Pretty sick. So this is the final result that you all should be aiming towards, specifically for Flappy Bird. There's also, I believe there's Snake as well, right? And the cool part is every group has a slightly different GPU that you will need to implement. So some of your GPUs are going to have color, some of them are going to have more colors, some of them are going to be grayscale, some of them will be black and white, some of them will be a larger resolution, smaller resolution. So every team is going to be different. So yeah, you're totally welcome to ask neighboring groups, what does yours look like? And by chance, does anyone want to see what their groups looks like? Yeah? What? Oh, shout out your group number. 12? Okay. Let's see what group 12 looks like. Okay. Team 12. Team 12. Okay, let's see this. All right. So it looks a little bit more almost like cyan and maybe a little more muted. But I don't know if the resolution is any different, but there we go. So that's group 12's. Any other group? Okay, 6. Yeah, we can try 6. Okay, let's see. 6. Hopefully it looks very different. Oh, look at this. Black and white. Okay, cool. Oh, actually not black and white. Grayscale. Very cool. Okay, I won't do any more, but but yeah, great. So let me also show you so this is the end goal. Let me show you kind of the first things that you will need to do, which are just getting the GPU tests working, which the first one is image. Let me do that really quick. Yeah, sure. Okay, sorry. Build.teams6 GPU image.slug. Okay, so here happens to be the output of Team 6's image.slug. And if we want, we can open up this provided PNG file. So every team is given a PNG file that explains what that image.png should look like. So here I can open it up, and there we go. So here is image.png of of team 6. If I want, I could open up team 5, and I could see what like this one looks like. So you can see like every team has a slightly different image that they will need to implement. So this is what should be displayed to your screen. So if you have any questions about what the output should look like, you can just look at image.png. Okay, so that is image.png. The next one is, let's do input. Okay, .slug, sure. Okay, so here, is input.slug. You can see that nothing is being drawn to the screen. And instead, what is happening is we are continually printing out, right here, we are printing out the values of each of the controller bits. So if I go and like press some of these, so if I like press, that's right, or like left, you can see that each one of these, like if I press them all down, you can see these are all the left and right, directional buttons, okay? I can also press like A over here and B, and I don't remember which one is, okay, it looks like then here's start and select. So here we go. So this is what should be outputted for input. Notice something kind of interesting though. So if I press all D-pad and then I go and press A and then, so right now I'm pressing all the directions and A, but now I'm going to also press B. Okay, so I'm now pressing B. Okay, do you see the issue on the screen? So I'm currently pressing all the directions and A and B, but what is it outputting? How many buttons does it say I'm pressing? Yeah, it doesn't say that I'm pressing any buttons. Yeah, if I let go of B, then look at that. Now it's saying that I'm pressing 5 buttons. Okay. Anyone seen this before? Anyone know what this problem is? We got any gamers in here? Anyone? No? No one? Anyone seen this? Yeah? No? Okay, so this is a quirk with basically all keyboards. So this is not a bug with your emulator. If you see this, and you will undoubtedly see this unless you have like a super fancy gaming keyboard or something that prevents against this. But there is a limit to how many keys you can actually press on a keyboard. And it's called like N-key rollover. So if you want, you can look this up. But yeah, anyways, just want to throw that out there. So you are unable to press all the buttons all at once, and it's a problem with your keyboard, not with your emulator. Okay, I'm going to get more questions about this, I'm certain. But if you see another group that's stuck on this bug, now you know how to answer it. It's like, oh, it's probably a quirk with your keyboard. It's probably your emulator is probably fine. Question.
I just wanted to know, like, so basically, in order to input all these like inputs that you're seeing here,
Mm-hmm.
you need to have like the window open and running.
Yeah, good question. So the question is how to get the input from your keyboard. So SDL allows you to get your keyboard's input, using like this window. So you can just kind of Google around like how to get user input using SDL. You can just Google that. There's tons of resources. And basically what you'll see is it'll be called like a key event, and you will just read what key event it is, and you will look at what key the key event is, and it's like, oh, if it's left button, right button, and I believe there's like key up and key down, so you'll just have to create like a little toggle inside that. So that's something, there's tons of resources online, but specifically, good question, you get input using SDL. Yeah, cool.
And then what we're seeing in the output in the console is outputting.
So what you see in the console, this is the slug file. The slug file is just a C program that what it does is it reads in the controller data, and then it displays it to the screen like this. Exactly, yeah, and that's what the slug file does. Yeah, cool. Okay. By chance, does anyone remember? Okay, really quick. So, does anyone remember the 4 memory mapped IOs that you already had to use for checkoff 1? What was one of them? Not quite. Not data section. So the I/O section of memory. So there was like std out, std in, std error. Yep. And then what was the last one? And then stop. Yep. Cool. Okay. So all we're doing for this is we're just adding another one, which will be the controller data. And so that controller data, anytime we read, like anytime the slug file wants to read from that address location, instead of reading from your big address array that you probably have, instead you will just go and read from whatever SDL is currently generating, like what it has read your current keyboard buttons to be. Okay, cool, good, excellent. Okay, yeah, I think, yeah, okay, good. So next what I wanted to briefly mention is how the data is stored inside of the VRAM. And we'll just take like a second to kind of talk about this. And like I said, every team is going to be slightly different, but in this case, we'll just look at specifically the instructor example team version that I have right here. So here, I talk about the GPU and the VRAM. So as your implementation currently stands, as long as you've done everything correctly, what should happen is your CPU should be entirely done, your memory unit should be entirely done, and you should be able to take in any program and perfectly implement it. And, you should be able to take in any program and perfectly run it with no issues, like it should all work exactly, all the memory should be filled correctly. And all the GPU does is it just monitors the memory that is in the memory section. So it won't, there's no extra like instructions or features that you need to add outside of just the GPU will just occasionally, it will look at what is inside of your memory and it will display it to a window. So yeah, in this case, okay, cool. So the GPU, yeah, it is responsible for decoding the video RAM, so the VRAM, and rendering its contents to the screen. So anyone heard of VRAM before? Okay, good, yeah. So graphics cards will usually have something called VRAM. And VRAM will usually store things like textures, right? It'll store maybe like shader data. It might store, like if you were doing like matrix multiplication stuff for AI, it might store like big matrices, right? This is things that like VRAM inside of like a graphics card would have. And off top of anyone's head, does anyone know how much like the new 5090 GPU, like how much VRAM that has? Yeah. No? Yeah? I believe the 5090 has 32 gigs. Yeah, and like the 5080 has 24, and yeah. But fairly kind of small numbers, right? Because usually, like we're used to, like if you have like a supercomputer that's worth like $10,000, you might easily have like a terabyte of RAM. My laptop right here has 32 gigabytes of RAM. But yeah, like all sorts of like laptops and computers can have like large amounts of memory to store these textures, data, and these matrix multiplication inputs and all these big things. In our case, we only have just like a few kilobytes, and all we are storing is something called a frame buffer. Okay, so we're not storing any sort of like texture data or shader data. All it is it's just a frame buffer. And that means that every individual like byte in your memory, like generally like each byte will represent 1 pixel on the screen. So in this case, I'm actually, I believe it's actually 2, yeah, so in this case it's actually 2 bytes for 1 pixel on the screen. So let's, I'm gonna quickly draw it out. Okay, there we go. Cool, okay. So if this is our screen right here, let's say it's 100 by 100 pixels, 100 pixels. Okay, and let's say each pixel requires 1 byte to store. Maybe we just have black and white. Maybe it's just a Boolean. Maybe it's either just the value 1 or the value 0, but it's an entire byte. So in this case, how many bytes are needed to fill out the frame buffer for this entire thing? How many bytes is needed to store every single pixel here? Anyway, you can just shout it out. Yeah, 10,000, right. So this, in order to represent every single pixel in a frame buffer, this would be 10,000 bytes. if it was like one. If it was 1 byte per pixel. Yeah. And let's say that our VRAM, so everyone's VRAM is going to be in a slightly different spot in your implementation, but let's say that our VRAM starts at address 0x5000. Okay. So this is the case. Then where would the index of this first pixel be? Okay, yeah? It would be just at 5,000. Yeah, yeah. So the first pixel is represented by the first spot where your VRAM is. Okay. And then the next pixel will be whatever, like the next spot in your VRAM is. So it would be 5,001. And all the way up, and like it would be 5,002, 5,003, be all the way over until eventually it would be at, I guess, number-based conversions, but it would be at like 5,000, OX 5,000, then plus 100 pixels, or I guess 99 pixels would give you this one. And then to get the next row, then it would just continue sequentially. So there would be like 100 elements all in a line that would represent the first like row across the screen, and then to start the next row, it just happens immediately afterwards like this. Okay, so that is how the frame buffer will, that is how the frame buffer is represented in memory. Okay, does this make sense? Okay. Does it? Do you now have like grand ideas on how to potentially implement this and get it working for your design? Okay. I'll tell you that SDL has a nice canvas option that you can just draw to, where you can specify a width and a height, and you can just start writing in pixels. So SDL allows you to do this. Okay. So if we scroll down a little, so if we look at when the rendering actually happens, it says that we render the screen. Upon completion of each loop iteration by the CPU, the GPU will then decode and display the contents of the frame buffer. So once we finish the loop, what you probably have at the moment is you run loop, and then immediately you run loop again, and then when you finish loop, then you run loop again. That's probably what you all have. So now you will just add in a little step, right? Like after you run loop, that will probably be like gpu.render, and then it will just probably fill out your big SDL canvas by reading out. Oh, sorry, I forgot I wasn't. That's okay. It'll just what render will do is it will just read out all of the different bytes inside of this big frame buffer array, and it'll put them into your SDL canvas. Okay. Makes sense? Any issues with this? Feeling okay? Questions? SDL? Yeah, SDL, lots of great resources online. I'd recommend just playing around with it. You can give this whole problem to ChatGPT, and it'll give you a pretty good explanation. SDL itself is not the most important thing, but understanding frame buffers is probably very important. Lots of GPUs, like a GPU will likely still have a frame buffer, but it will also store like shaders and things. Okay, cool. Everyone looks very sad. Oh, good. Anyone else excited? Oh, good, okay. Everyone. Okay. Cool. So next, I wanted to talk about something completely different, which is a little bit deeper in the functionalities that C and C++ give you, unless anyone has any more questions. Okay. Oh, yeah, question. Oh, sure. Okay. homework 6, that was the one after inheritance, right? SDL.
I think you meant to say when you close it, it just stays open until you press the close button. Right?
Oh, maybe there's a typo.
Yeah, I think there might have been a typo.
Okay, let's confirm that. Yeah, thank you. Sorry, yeah, I did write it a little bit quickly. Okay, let's see. Oh, nope, that's a typo, yeah. And the window should stay open until the close button is clicked. Yeah, thank you. Let me fix that, yeah. Until, should stay open until. Good, okay, does that fix everything? Okay, cool. So, yes, okay, here it is. All right, take a second to absorb this, and then turn to the person next to you. What will be outputted by this? Okay. Any takers? What will be outputted? Okay, yes. What will be outputted to stdout? Correct. What number is that? Oh, yes. Not quite. Okay, behind. Yeah. It will be 1. Why is it 1? Yeah, so this is a uint 8, not 128. This is just uint 8. Yeah, and this is 1 byte. So let me just compile this super quick. Okay, so cd classes make. Okay, there we go. So print out 1. Very cool. Okay, what if I now do this? What will the new size be? So now I have 4 of these uint 8s. Okay, what is the new size? Can you say it? 4. Excellent. Okay, let's test that. Okay, and there we go. It says 4. Okay, good. Now let's add a uint 32. Okay, how many bytes is a uint 32? Yeah, so 32, so divided by 8 would be 4. So this is size 4, so we should see probably that we have 4 bytes and plus 4. So how many bytes total will be outputted here? Probably 8. Okay, let's check. Okay, 8. Great. Cool. Let's now add in another uint 8. Okay, you all are experts at this. Okay, so what would probably the new size be? So we have 4 bytes here. Then we have one 4-byte value here. And then we have another 1-byte value here. So yeah, if my math is correct, it should say 9. Okay. Okay. Anyone not think it's going to say 9? Okay, 9. Okay, let's see. Okay. What the? Okay, turn to the person next to you, ask them, why the heck did it output 12? Because there's only 9 bytes being specified here. So ask them, why did it turn to 12? Okay, talk about it for like 10 seconds. Okay. Any thoughts? Why is this happening? Yeah. Exactly, yeah. So there's something called padding in C++. And the thing is that look, let me write it down. So padding. Yeah. So what is really cool is anytime you create a class, it will add padding around each of the members. And this helps for caching, and it helps with additional optimizations. And there are a lot of reasons for why they choose to do this. One downside, though, is that now we've just created unnecessary memory, because now you can see the size is 12 because it's now actually just inserted a bunch of extra bytes like right around this region. And so that's unnecessary if we're very worried about how much memory we're allocating, but it ends up kind of being nice for the most part. Okay, let's now, I don't know, let's experiment with this. So now what would maybe the size be if I change this to 16 right here? Okay, take a second, talk with the person next to you. What happened now? Okay, any guesses for what will be outputted? Okay, yeah? 12? Okay. Any other guesses? We're thinking 12? Okay, let's check. Okay. 16. Okay, maybe a little weird. Let's move to the iPad really quick, and I'll show you kind of what's going on here. Also, note that this is not actually a C++ standard. So everything that I'm going to show you, this is specifically what's happening when compiling using G++ 12 on x86. It depends entirely on whatever your compiler is and whatever architecture you're on. So it's completely different on every computer, but I'll show you kind of what's happening in this case. So the first thing that happens, if you remember, so first let me write out the sizes of everything. So I have a size of 111, then 2, then 4, then 1. So this is the number of bytes of each of the members in order. Okay, so in theory, like if we added these all together, that's what we initially thought the size of our class would be, but that's not what happened. So let's take a look, and what I'm going to do is I'm going to find whatever the largest size member is, and I'm going to treat that as our like block size. So here we have this block right here, so size 4, and what I will say is I will say any variable is not allowed to be split across a block boundary. So in this case, do you remember, so what is the size of our block? Our block size is 4, yes, because we have because that is what the largest size member is. So in this case, so okay, if we put this first element in, so it's 1, then 1, then 1, and but are we allowed to put in 2 after that? No, we cannot put in the 2 because that means that 2 would be split across a block boundary. So okay, let me then create a new block, and I will put a little X here just to denote that this is unused space. Okay, then we can create a new block, and what goes in this new block? Okay, 2. Okay, can we put in 4 after this? No, we can't. Okay, so therefore this is 2 bytes of unused space. Okay, then after this, can we put in this next element? Okay, we can. How much of the block does it use up? Yeah, so this element is size 4. This is our largest element, so this will take up the full size. Okay, can we insert 1 into this block? No, so we'll need to create a new block right here. 1. And now how many unused bytes are in this block? We have 3 unused bytes. Okay, so therefore, how many bytes total did we use? In total, so each block is 4 bytes, and we have 4 4 blocks. So therefore, in total, we have 16 bytes used. And that is what we saw by running G++. Yeah, so 16 bytes used. Okay. Can anyone think of a way to potentially reduce the number of bytes created by this object? Oh, yeah.
You could change up the order. For example, move that first byte all the way up top. That saves you at least 1 block.
Oh, sure. Yeah. I like that. So we could reorder these. So I'm going to duplicate this really quick. Bring it down to a new page. Yeah. Cool. So the suggestion was to bring this first byte, maybe just move this down here.
It's the opposite, actually.
Oh, the last byte? Oh, okay.
So that saves you a block.
Oh, sure. So if we move this first byte, yeah. So if we just move this up there, okay. So now then we will move this over here. Okay, and yeah, it looks like we can just eliminate this last block. So cool. So now we only have 2 unused bytes. Okay. Can we do any better? Yeah, I don't think we can do any better. I think that is the best we can do for this amount. Cool. Okay, so that's padding. Kind of fun. Okay. You might see a question on your quiz about padding. It might be like oh, here are 3 classes. What are the sizes of each of them? And they will have maybe like different orderings of variables. So feel free to play around with this. Okay, padding. Good. So now, once again, I kind of want to swap around a little bit, but I want to think more about memory. So this is kind of a cool thing. Like, yeah, in other programming languages, you don't really think about memory like at all. Like, you don't really think about the ordering of bytes and variables. Like, this is a very kind of C++ or C type thing. Like in all other languages, you just kind of assume that everything, like you just assume that you have infinite memory. You don't really care. In C++, generally you write C++ because you really want fine control over your memory. And one of the favorite things that C++ engineers will do is they will try to do things entirely within compile time, and will try to actually not use any memory at all, like exactly 0 memory. And they can, because what you can do is in C++, you can actually move certain things to compile time. So for example, I'm going to remove this. So if I say so if I say int a equals, 3 plus 4. Okay. What value will a store here? Right? Yeah.
7.
It will store 7. But maybe that's a little bit maybe that's not super trivial, though. Because looking at this, maybe the first thing I would think is, well, first maybe it equals 3, and then we perform an add I instruction after that. Well, then where it will add 4 to it. So maybe I would imagine that A actually takes on 2 different values. But I think even if I hover over it, I guess it doesn't. Okay. But this variable actually, it stores 7 right away. And that's because G++ will do optimizations for you. It will recognize that this is something that it can figure out at compile time. When you are hitting compile, when you're compiling it, it will automatically realize, hey, wait, I think this is 7, and it'll just put in the value 7, and it won't, do this add instruction anymore. And that actually ends up saving some time. Okay, very cool. Well, let me show you this other project right here. Okay. So what this should do, so we have this main kind of function right here, which is called maximum prime difference. And the name isn't super clear, but basically what it's saying is, if this is maybe it's some sort of like leak code question at some point, the idea with it is you want to find the maximum distance between any two primes in an array. So here we have this array. Okay, what is the first prime in this array? It is 2. Yeah. Okay. So this is the first prime. What is the last prime in the array? Okay, it is 3. Yeah. Okay. So here's the first element that is prime. Here's the last element that is prime. How many steps away are these two elements from each other? Looks like they are like 3 steps away. So we have like 1 step, 2 steps, 3 steps. So it looks like the total distance between these two elements is 3. Okay. And then here I have this algorithm that finds them. So I start from the left side and work to the right. Then I have start on the right side, work to the left. And then I have this isPrime method right here. And I don't have like every prime number accounted for, but I have maybe at least the ones important for this example. And then I perform binary search just to check like if a number is prime. Okay. Well, question for you. So it's by us looking at this, what did we say should the output be? What did we just say the output should be for this? Okay. Yeah? Huh? Oh. So the output for this, so it is the distance between 2 and 3. What is the distance between 2 and 3? Yeah, so the distance is 3. Okay, did you need to compile that? Did you need to run that in order to figure that out? Okay, you kind of just looked at it, right? And then we could just look at it. We know immediately, okay, it's going to return 3. So actually all of these functions are they're not useful. Like we know that the answer is going to be 3. Okay, but if I were to compile this, what it would do is it would still create these functions and it would end up running all of this and it would take kind of a while. So the question now is, can we perform this now in compile time? Okay, so what I will show you is I have this make file right here. Okay, I have these wildcard things right here. So I will now create this .s file. .s generally means like source, like assembly. So I'm going to generate assembly, like I'm going to compile the CPP file into an assembly file. And notice that I can make an assembly file with this -s argument right here with G++. I'm also using C++20, which is going to give us like extra cool features, which we'll see in a second. But okay, so I'm specifying this -s, and what this will allow us to do is access the assembly output. So I'm going to cd to maximum, okay, and we'll make main. Oh, I actually meant to make main.s. Okay, good. So I just made main.s. We want, that's fine. Okay, so here is main.s. Okay, good. So we can see everything that happens inside of this. Very exciting. If I want, I can try to search for this like maximum prime difference. Not sure if it'll show up. Oh, it does. Okay, good. So yeah, here we can see this maximum prime difference function right here. Yeah, here's the text section. Here's the actual function right here. So here are all the different instructions that go into implementing this function. You can see all these jumps and things, and there we go. So here is the maximum prime difference function. Good stuff. Okay. If we try to find like main, we could find main as well. Okay, here's main, and yeah, and you can see that it eventually, yeah, so here you can see it does this call instruction where it will call maximum prime difference. So even though we know that the answer should be 3, instead we're seeing that it's actually running all this. Okay. Anyone know how we can move this to compile time? Anyone seen this? Yeah? 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 Yeah, const expression. So this is a new C++ feature that I will show you. So const expression is saying, hey, like I think we could actually run this at compile time now. And so what I could just do is now on each one of these functions, I can say const expression, const expr, and this now says like, hey, like please try to run this as if it is a, as if this is only for compile time. Okay, and I can do this, and there we go. It looks like I'm getting an error. Maybe not anymore. Okay, let's see. And you know what? Let me make this array of primes. I can also make this const expression, this array. And what this will do is now this array will actually not exist anymore in memory. Instead, it will only exist at compile time. So this primes array, complete fairy dust does not actually exist after we've compiled it. It exists only in the compilation stage. So okay, let's see here. So if I now do make main.s, okay, let's see if that worked. Okay, if we try to find main. Okay, so here's main. Is that right? So here's main. Okay, so it looks still kind of long. All right, so it's still, it looks like it didn't quite optimize out everything. It's still adding in a bunch of code, okay? Okay, so the reason for that, I believe, is that instead of const expression, so here like we really want it to run at compile time. So instead what we can do is use another keyword. Let me actually first write it out. So const expression functions now can run at compile time, but they're not. So a const expression means that it doesn't enforce that functions must run at compile time. But that's where a new keyword comes in called const eval. Functions now must run at compile time. So now let's go and test this out. So const eval. Okay, good. And const expression variables. Good question. Variables must only at compile time. A const eval variable does not exist. Const expression applied to a variable means that the variable must only exist at compile time. Okay, so let's see. Hopefully this fixes it all. So if I now make this, okay, good. So let's see. Okay, oh, wait, look how much shorter it is now. So it's only 65 lines. If I now look at main, okay, oh, look at this. Look how short that is. Okay, what's happening here? So we're moving 3 to the EAX register, and then we return. So that's all that main is. So effectively, what we're doing is we are now returning the hard-coded value of 3. And look how much simpler this whole program is. Now all we're doing is just returning the number 3 because we are able to run all of this at compile time. At compile time, that is when this algorithm was run, and now it figured out oh, okay, instead of returning instead of generating all these function calls, instead I can just return the value 3. Isn't this cool? Yeah. So this is something fairly unique to C++. I would say maybe it is, in my opinion, maybe one of the coolest things about C++. Other languages can do similar things, but this is really cool, and we'll see how much more we can take this. Okay. Question in front first.
Just a curiosity question.
Yeah.
Is it making assembly instructions, executing them, and then just deleting them, or how is the compiler evaluating your code?
So the compiler, that's a good question. I'm not certain how const eval, const expression is actually implemented by G++. I'm actually not certain. I'm guessing, I don't know. I guess I kind of just take it for granted. In my head, I was assuming that it was interpreting all of your C++, and it was just finding ways to optimize it. But I'm not actually certain. But overall, this is just a very cool way of simplifying the assembly output. I can look more into that though. Other questions? Yeah, sure, cool. Another thing, like I said though, so this primes array. So since this only exists in compile time, the question to you now is, so when I run this program, how much memory on the stack does primes need to allocate? How much memory on the stack does primes need to allocate? Okay. Yeah, question or answer. Yeah, exactly. It doesn't allocate anything. So by putting this const expression right here, this primes array allocates 0 memory. And that's super cool. That's super awesome because now, like, if this was a huge array or something, then we wouldn't want to like allocate that memory every single time we call isPrime. Like if we call isPrime a bunch of times, it would really suck if we had to reallocate that memory and delete it, reallocate, delete. Like that would really suck. But instead, we can just say const expression, and then now it's all kind of just figures it out in compile time. Yeah, question? So size of primes would still evaluate to whatever the size of array is, which I think would probably be like 16 or something, because size of will calculate like as well at compile time. Like it will see like, oh, the size of std array is this size, although it won't show you, I guess if we, it won't show you it won't show you whether or not the data was created on the stack. It will just show you the size that it would be if it was created. Yeah. Yeah, good question. This is cool. Okay, let me show you another example. Okay. Good. So here, hopefully this is fine. Okay. What is the issue here? Hopefully this is fine. Let's see. Okay, so I now have this new project right here. So this is a simple array class, and all it really is it's just a wrapper for std array. Std array is very similar to std vector, except instead of it being a dynamic array, instead you have to specify the size of the array with this argument right here. If you remember, so this is called a template. The idea that you have these brackets like this, and inside this you specify usually either like a type, or you can specify like an integer. So here we're giving the type, which is most likely like going to be a type of int, and then here we give the size of the array. And then around this wrapper, then we have this max, min, and contains method right here. And I actually want to get rid of that. Okay. Cool. So the question now, the question now is how to use this in order to make it const expression, in order to make it so that if we wanted to create this array class, we could use like a similar thing where it just evaluates it all at compile time. Okay. So take a second and think about how we could modify this class and how we could use this class so that we don't take up any space, like we don't take up any memory, and instead all of the computation is all moved to compile time. So take a minute, maybe talk to the person next to you. How can you utilize this class in a const expression way? Okay. Hold your thoughts. I'm going to show you another kind of quick C++ thing. So here I have std initializer list. Anyone seen this before? Okay, cool. So an initializer list, the idea with this is kind of like a primitive list. Like if you think like a primitive, if you type in like 1, 2, 3 or something, like that's a primitive. It's something where you like inline can instantiate something. And so here we have this like array primitive. This is called an initializer list. So what this constructor is doing, so yeah, we're constructing this array object, and we are passing in this initializer list into the initializer list constructor right here. So that is what the initializer list is it will take in the like curly bracket and then comma separated values, primitive. So that's all this is. So now you've seen it, so now you're experts. It's not too complicated, but it's really valuable if you want to make your class APIs like really elegant and cool, where you can just like pass in an array. So you would use an initializer list. Okay, so if we look at this output right here, so here I have this array right here, so it has 3, 1, 4, 1, 5, and then we have max value, min value, and then has 3 and has 10, and then here I go and run each of these, and then I'm returning max value. So you know what, let's actually, this is fine. Okay, so now I can go and run this, so I just compiled it. I can compile it again though, so I can do /main. And so we can see, okay, so the max value is 5, minimum is 1, it contains 1, and it does not contain 0. Okay, what can we do now in order to make this work at compile time? Okay, thoughts? So the first thing that I would think of is if I want this array object to exist only at compile time, then I would probably want to explicitly say that. I would want to say like, hey, this array right here, I'm going to put on this const expression thing right here. So I'm now forcing this object, I'm forcing it to be a const expression object. And we're seeing this compiler error, which is good. That means that we have like an error in compile time. Compile time errors are much better than runtime errors. So this is totally fine. So okay, so it says const expression variable must have literal type or reference type. So basically what it's realizing is it cannot call this constructor. It can't figure out this constructor. Okay. Any guesses for why it cannot run this constructor? What do we need to add to a function in order to allow it to be runnable at compile time? Okay, yeah? So this constructor right here, so this constructor, we will need to add const expression to it. And when we add const expression to it, it now means that this function is allowed to be run at compile time. And if we now scroll down, now our error goes away. Okay, so let's see what happens. So if I do now make main and /main, okay, cool. Okay, looks like it worked. Let's double check though. Let me comment out all of these guys right here, and let me run this again. Okay, so I'm running it. Let me also actually make main.s. Okay, so now I can open up main.s, and I can check out this main function. So main. Okay, here's main, and is that good? Yeah, so here we can see that it is, in fact, just immediately returning 5. Super cool, yeah. And if we wanted, we could add these back now, okay? If we add these back, what do you think the assembly will look like now? Do you think it will now say, do you think it will now start running each of these functions and it will take like a really long time? And, what do you think the new output will be if we add back all these print messages? Okay, yeah?
Those functions don't have const expression, so wouldn't they have to be calculated at runtime?
Well, so these functions, these are like I/O functions, Right, so you can't even run these at compile time. The whole point of cout is that, yeah, it's exported to the console at runtime.
Sorry, I was talking about the max and those don't have constant expression.
Right.
So they would be running runtime?
Sure. Oh, yeah, good point. So, yeah, here we're noticing that that each one of these are not marked as const expression. Yeah, so it might have to generate these. But also, like, this array already is const expression. So in that case, it might already be able to optimize these to become const expression. But sure. But what we can do is we can just be extra clear about this. We can make all these const expression. Okay, so now let's see what happens. Okay, sure. Cool, okay. So now we're getting an error. So if I make these const expression, then now it's getting mad at me. It says that it can't find max, min, and all this. What is the fix to this? Yeah, so now we just need to add const expression on all of the remaining functions. So let me just do that really quick. Okay, good. Const expression. Okay, so now I run this. Okay, good. So it looks like it ran. If I now look at main, then we can see that, well, it seems like it's doing quite a bit of stuff, but in the end, it still is just doing this like set EAX register to 5. And so even though it's doing all this, and you can see what it's mainly doing is just calling this function right here. What does this say? OStream. OStream, that is just cout. So cool. So even though, like, yeah, it has to do all of these like printing functions right here, in the end, it ends up being still really fast because all of these parts are done in compile time. Yeah, pretty sick. Any last minute questions? Okay, highly recommend trying to find where to use const expression just all the time. I love const expression as like an embedded systems guy, chip design guy. I honestly feel like I write more variables as const expression than not. That's kind of just who I am. Yeah, question?
Yeah, I was just curious because I assume you're teaching us this so that we can use it in our final project. Where do you think this will be best utilized?
So actually, const expression, not super useful in the final project, but places where you could use it are for declaring, like helping declare magic numbers. If you want to declare like specific memory addresses and you don't want to use a const member, but now you could use a const expression member. Now it will create 0 memory when you create like that hard-coded, I don't know, address to address, yeah, OX 7000 or something. Other use cases, yeah, I can't think of any off the top of my head, but it will be definitely helpful for your homework 7, which will be posted soon. Yeah. Sure, cool. Okay. Well, on Friday, we're going to talk about templates. So thank you very much, everyone, and I will see you on Friday. Please feel free to come up with any more questions.